Okay, so our first two types of transformations for transformation geometry are translations and axial symmetries. Now, with these, what you have is translations and axial symmetries, and then central symmetries are kind of three more basic ones, and then we have our rotations, which are the slightly more difficult ones, which I'll have a look at in a minute. So, first of all, with the translations, what we have is we have two pieces of information that we need. We need an angle and we need a distance, okay? And depending on the question that you have, you can be either given it as an actual angle, you could be given the point where an object starts and then the point where it finishes, and you'll have to find it that way. Or sometimes it'll be equal to a line, okay? And if it's equal to a line, the line you would have is whatever angle the line is at and whatever length the line is, that would be your angle and your distance. So what we have with it is you would always start off with your object, okay? So we have the object here, which is ABC. And for this one, we're just told this is an example of translating 30 degrees, 50 millimeters. So what we would do for that then is project each one of the points of my object, each one of the points here, project them at 30 degrees. And then with your compass, set your compass to 50. So the compass will be set to 50 millimeters. And then each one of the points will be swung 50 millimeters from each one of the other points here, okay? And that will give you then your image for where your points end up, so where your shape ends up over here, okay? And then, as I say, depending on the way that you're given it, if you were given a line, you might be taking the distance on a line and then transferring it across. Or if you were given where one point starts and then where it ends up, you would take the distance between the point where it starts and the point where it ends up. Okay. The second one then is our axial symmetry. With the axial symmetry, what we always have is we always have an axis, and we have an object again here. Okay. And what we have for those is, so our object and our image, what we have is we have the object, the axis, and then the image. So we have object and our image. So to do this one, all we do is that we have our axis, so we'd normally be given the axis, or as we go on into the more higher level stuff, we'd have to find the axis. But what you have is that each point from your object to your image is the same distance on either side of the axis, okay? So what we have first of all is, if you want to do one of these questions, is you take your point, you project it at 90 degrees to the axis, okay, so 90 degrees to the axis my line will come across, and then you take the distance between the axis and the point, okay, and then it always goes the same distance on the other side, okay. If I was then doing B, then I would go from the axis to the point there, and I would swing it over to the other side, and for C here, I would go from the axis to the point C over here on the other side. Now, the thing is that the axis won't always be vertical. So in this example, I have it as vertical, but this axis could be at any different angle. But the important thing, and the most important thing, is that you're at 90 degrees to whatever the axis is. Okay, so the angle between your projections and your axis will always be 90 degrees to each other. Okay, so in this case it's vertical and horizontal, but you could have one that was at a different angle, and you would have to make sure that the projection is at 90 degrees to the axis. Okay, and then it's the same distance on either side. Okay, but the mistake that most people make with this is that they don't project at 90 degrees to the axis, but that is absolutely vital. So axis is here, project at 90 degrees to it. Okay, that doesn't matter what angle the axis is at, as long as you project 90 degrees, you'll be fine. Next up then, we have our central symmetry. Okay, now mine's going a little bit too far here, but we won't worry too much about that. With a central symmetry, what you have is you have your object, so your object where it starts, and so your object's there, and we have then our image where it ends up. Okay, now with a central symmetry, what you would be given is you will be given your object, and you would be given your center of symmetry. Okay, and then as time goes on with the higher level ones, we'll have to find a center of symmetry, but that's later on down the road. So what we have is we have our ABC here, and we have the center of symmetry. Now, when it comes to the center of symmetry, what you always have with this is you always project, each point goes through the center. So we'll have our point here first, so point out through the center. And then what we make sure then is that whatever distance the point is away from the center on one side, so with my compass here, I'll set my compass over to it on this side, I make sure that it's the same distance on the other side. Okay, so each point is always the same distance from the center of symmetry. So that would be A. I could do the same then here for B. So I have B here. Okay, so what I again would have here is for B here is I would have the center. I would take my distance at B, swing it around, and I'd get B. Okay, and B would be over on the other side here. And then finally, I'd have my C. So C will come across here like this. And C then is the same distance on the two sides. So I'd have C here, I'd have C over on this side. I would take that distance and swing it over to the other side. And then I get each one of my points. Now, the most important thing with the central symmetry, okay, more than the other ones, is to make sure that you've labeled your points. Okay, if you don't label your points here, or if you've gotten to this point and haven't labeled them, then it's very easy to make a mistake when joining them up. Okay, but if you've labeled them, so if you label C, you've labeled B, and you've labeled A, then when you go to join these up, it's very simple. But if you haven't labeled this, then it can get very confusing because you can join the wrong points. Now with a triangle, that's not going to be an issue, but when you get onto more complicated shapes, it really becomes an issue. So the labeling is really, really important when it comes to this. Okay, so really, really think with your central symmetry and all of them, but particularly with your central symmetries, make sure that you put in your labeling. Okay, it makes it a lot easier to see what you're doing. Okay, finally then we have our rotations. Okay, now the rotations are generally the ones people find the most difficult. So if that is you, not to worry, it's the kind of most people are the same. Now what we have with the rotations is that we have to be given 3 pieces of information for rotations. Okay, so number 1, you have to have a center. Okay, number 2, you need a direction. Okay, so that would either be clockwise or anti-clockwise. Okay, so we have to have those 2 pieces of information. And we need an angle. Okay, so they're the 3 pieces of information that you absolutely need to be able to do a rotation. Okay, now as time goes on and you do the higher level constructions for these, you might be given just 2 of these and you have to find a third. Okay, but there's ways and means of doing that, and that'll be in the notes page for the higher level. But at the start, what you'd always have is the center, the direction, and the angle. And once you have those 3 things, even when you get on to doing higher level ones, once you've found all 3 of them, then your method for doing the rotation is the same as this. Okay, once you've actually found all 3. So for this one, what we have is, as an example, is we want to rotate 65 degrees about point P clockwise. Okay, so what we have here, so the center is point P, the direction is clockwise, and the angle is 65 degrees. Okay, so they're the 3 things. So we're always looking out for those, and if we don't have them, we're looking to try to find them. To actually do your rotation then, the first thing you do is you join your point back to the center. Okay, so in this case you would have point A was joined back to the center P. Okay, the next thing you do then is with your protractor, so with your protractor is put it onto the line that came from the point. So for this one, the orange line comes from A, so I put my protractor on the point P and line it up with A. Okay, then I'm going to measure 65 degrees, okay, and making sure that I count up to it. So, 10, 20, 30, 40, 50, 60, 65, okay, so that would be my 65, and I get the second orange line, okay. And what I have then is I have a 65 degree angle between these 2 orange lines, and then I can get my compass and swing from the center to my point, so this is for point A, to my center, swing it up, and where it hits that orange line that's after coming up, that gives me my A1. Okay, now in this example, B is on the same line. Okay, so B and A are on the same line. That doesn't happen very often, but in this case we have that. So B will be joining back. Because it's on the same line, it'll end up on the same line up here. Okay, so that's A and B, so B rotated up then. Then if you want to do D then, so if I was to do the D one, again, I join back, this time at my from my point to my point P, and I set up my protractor onto the line that came from D. And this is really important. This is the bit that will help you get it right or wrong. It comes from the line, from the point, okay? And up here, then we have 10, 20, 30, 40, 50, 60, and 65, okay? And I get my second green line here, so this green line up here. So the angle between this green line and this green line is 65 degrees, okay? That projects up, and then my D is rotated around the point P with my compass, okay? And then that gives you my D1. Then finally, then the point C then comes back again, joining point C up to the point P. I measure my angle of 65 degrees using my protractor, and then I measure up again 65 degrees, so 10, 20, 30, 40, 50, 65. Draw my second line up here, so I get my third yellow line up, my second yellow line, but my third line's coming up here. Comes up, and I swing from C up onto the yellow line there, and I get to point C1. Now, because I've labelled everything in this, so this is very similar to this one, because I have each one of these labelled, it's very easy then for me to join them back up again. Okay, so A to B to C to D, and again A, B, C, D, and once you have it labelled, it's very easy to do that. Okay, and that is a rotation. So what can change with the rotation is that you might be not given one of these, okay, in which then you go and have a look at the higher level constructions. But once you've done the higher level constructions, you'll have all three of those things, okay? And once you have all three of them, then every rotation is the same as this, okay? Except you might have a different angle, and you might be looking at it being anti-clockwise instead of clockwise, but you'll see that as it goes. So your clockwise again is going up in this direction, so the same as the way a clock goes. Anti-clockwise would be going the other way around. Okay.